Thanks. All right, everybody. My name is Rob Simmons. I go by Utkanos, which means duckbill platypus in Russian. Today we're going to talk about open source malware labs and how to tie a bunch of open source tools together to operationalize them and get some data out of them. And I'm also going to show you a few highlights of certain tools and how to really get good information out of them when you're using them as malware analysis tools. So, who am I? I'm the Director of Research Innovation at ThreatConnect. We are a threat intelligence platform, so come check us out. But to start off with, I want to answer the question of why you would need an automated malware analysis lab. Like, what is the purpose of this? So, the first purpose is for malware research. And this is just general research. If you are doing it for yourself or if you're doing it professionally, discovering new types of malware, discovering new types of exploits, discovering new types of drive-bys, monitoring different adversaries and their activities. And as you can see on the side of the slide, this is from Lenny Zeltzer's website, and this is the difficulty levels of the different stages of malware analysis. So at the bottom we have fully automated analysis, and then the next stage up is static properties analysis, so static analysis. The next stage up is interactive behavioral analysis, and then the top is reverse engineering using manual code reversing. So each of these is progressively more difficult, and my talk today is going to talk about the bottom two rungs of this difficulty pyramid. So what are some of the other things you can do with a malware analysis lab? You can enhance your threat intelligence. So if you have certain malware binaries that you've collected from your own enterprise, or you find some in a blog post somewhere, you can process it yourself and either confirm the research of someone else or enhance the research and get more C2 IP addresses or more features from the malware. And additionally, you can use this as part of your malware hunting process. So if you're hunting for malware, it's always good to have an automated malware analysis system that you're funneling the malware through first before you go through some of those more difficult stages, because if you get something, you can get value out of the automated processes before you need to spend time on those more difficult processes. And then it's also important for network defense. So if you have network intrusion detection systems that are doing packet capture and they're carving files out of the network traffic, you want to take those files and then process them using an automated malware analysis system to get a head start on the analysis process. And then, of course, if you have an email server, you want to run attachments and URLs that are in your email system through an automated malware analysis system to check just to see, are you being attacked with a drive-by, or is this a legitimate URL? Is this a legitimate attachment being sent to one of your employees? And then finally, host intrusion detection systems will often find files and executables that are run on the endpoint. And then if the system is either unaware of them or they are the first time it's been run, they will often be reported back to the mothership of the HID system. And then from there, you'll have a repository of files that were run on your endpoints, and you want to run those yourself through an automated malware analysis system to find out if they are legitimate or not. And then finally, the reason why I do this is it's fun. It's a lot of fun. So to start with, there are 4 entry points into the malware analysis process that I'm going to talk about. I know that there are many, many more entry points into the process. There are many more minor entry points into the process, but these, I think, are the 4 major ways that you can begin a malware analysis process. So the first one you have here is a file. And when I say a file, I mean anything that's executable, and also anything that's exploitable by running or opening on your machine. So this also includes documents, Excel documents, PowerPoint. It includes Flash files. It includes Java jars. It includes PDFs and DLLs, anything that's executable. So these are all a file entry point into the malware analysis process. The second item here is a URL. And I'm going to narrow this down to two basic types of URLs. There are other types of malicious URLs out there, phishing URLs, and the ones that pretend to be a bank, and then you've got advanced fee fraud and other types of URLs. But I'm going to focus on two main types of URLs. Well, actually three main types of URLs, but one is sort of a subset of the other. So you have a drive-by, which is where someone visits a URL, and then unbeknownst to them, without any sort of interaction on their part, they are given a payload, and the payload is now running on their machine. So some of those exploits that work in tandem with a drive-by will crash the browser, or will crash Flash, and some of the better ones won't crash. So you'll see the user won't see anything occur, but they will be infected. The second type of URL that I'm going to talk about is just a payload malware download URL. So oftentimes you'll have a staged malware attack, and so the first stage will actually reach out to a URL and download just a file, the next stage from that URL, and then install that second stage or third stage malware on the workstation. So we're going to talk about those. And then the subset that I kind of hinted at is called a traffic diversion system. So these are sets of URLs that just one forwards to another and forwards to another. And then as your traffic travels down the TDS, many of the stopping points, or not stopping points, but forwarders on the TDS will look at certain features of your visit, such as your origin IP address, what the geolocation of it is, or what the user agent string that you're using, or sometimes if you have JavaScript running, it will actually enumerate what versions of Flash and what other versions of things you have. And so the TDS will make a decision: do I send you to an Angler exploit kit, or if you are a visitor that doesn't have any of the exploits that I am looking for, if you have a user agent string that I'm not looking for, you will get sent to Yahoo, or you'll get sent to Google, or you might get sent to the Canadian Pharmacy Mall and get a Viagra ad of some kind. So the third type, this is a PCAP. So PCAP is a packet capture. This is a recording of network traffic between 2 points in time. And so you get a picture of exactly how all of the machines that were communicating on the network and what they were saying. And so I like to say that this is like listening to the malware talk. So this is when you're looking at a packet capture of malware running, you're listening to what it's saying to its command and control structure, and you're also listening to what it's saying to its surroundings, if it's a peer-to-peer malware. And then a memory image, this is the final component or entry point into the malware analysis techniques that I'm going to talk about. So this, I also, like the PCAP, is what the malware is saying. I like to say that the memory image shows you what the malware is thinking. So this is an image of volatile memory, memory that's in RAM, all the memory pages. It could be of one process, or it could be the entire virtual machine, or whatever is, if you're using bare metal, then all of the memory on that machine. And this is a very rich source of information about what the malware is doing. You can dump processes. Sometimes if you dump a process, you may need to rebuild you need to rebuild some of the tables, and so that you can run it properly and see the imports. But you can get a lot of very good information from a memory image, and we'll take a look at that in just a moment. So for each one of these entry points, I'm going to talk about one open source tool. All of these are free. Any of them that you want to use, you can just download the source code, build it yourself. Many operating systems will have pre-compiled binaries of these that are installable via packages. If you use Mac, all of them except for Thug and Cuckoo are available in Homebrew. So you can use Homebrew to install these. You'd use Homebrew to install for volatility, but it's just a set of Python scripts. So you would actually install Python, and then you would install volatility and run it that way. And then Bro is just brew, install Bro. So each one of these matches up with the entry point. And I know some of you are going to notice that Cuckoo Sandbox actually serves more than just a purpose of looking at files. It also looks at memory images and includes volatility. But there's a nuance as to why you also want to use volatility by itself on a clean memory image of the malware. And I'll get into that in just a moment. There are some nuances there. Thug is a low interaction honey client. And so what this does is it visits a URL and it pretends to be a browser. So it's a set of Python scripts, again, with a lot of dependencies. And so it basically pretends to be a browser and tries to convince a web server that it should deliver its payload or to give the file that it needs to download to that visitor. Bro is a network security monitoring framework. You may know this from, it's in the class of software such as Suricata or Snort. These are used to detect unusual traffic and unusual conditions on a network. I'm not going to talk about Bro in that way. We're not going to use it as a network security monitoring tool here. We are going to use it as a malware analysis tool. And there's a very subtle difference here, because if you have a lot of packet capture from many different machines, I'm not looking at that right now. What I'm going to show you is a technique where you have one machine, one VM, you are running malware, you know that you're running malware, and then you're capturing the packets that malware produces. So this is using it as a malware analysis tool rather than a network security monitoring tool. So last but not least, we'll talk about volatility, which is a memory analysis tool. There is another memory analysis tool called Recall. There are pros and cons to using both, but I'll focus on volatility for this talk. So let's start with Cuckoo Sandbox. So Cuckoo Sandbox, as I said, actually covers a lot of your bases. So it's a static and dynamic file analysis system. This is a screen capture from one of my Cuckoo instances, and it provides any sort of sandbox, basically provides a controlled environment where you can run malware and then observe its behavior. In addition, Cuckoo Sandbox also basically gives you static analysis tools and output almost for free. I say almost because nothing is free, but compared to running an entire virtual machine for 5 or 10 minutes, or however long you've set the timeout for that particular run of the sandbox, running that uses a lot of resources, and the comparison between using that many resources and just doing some of the static analysis techniques is, light years difference. And so you almost get the static analysis for free. So each time this runs on a file, you get all of these other static analysis output at the same time. And what I want to do is actually focus on some of the really, really good things you can get from static analysis. I know that dynamic analysis is a bit more sexy because you get indicators of compromise, you get C2 URLs and IP addresses, and C2 traffic of different types. And these are the things that you're going to plug into a defensive device to protect yourself from future traffic of the same kind. But I'm going to step over and look at static analysis techniques and show you some of the interesting things and information that you can get from static analysis. So at the top, this is the output from strings. And so this, the sample that we're going to look at here is KeyRanger A. This is a Mac OS malware that was basically the transmission BitTorrent client was replaced with malware at 2.90. This was, back in February, March. And so I took the sample and ran it through the sandbox, and I found strings. And so there's a nuance here. When you have a piece of malware, the author will often run it through a packer, and before you are able to look at the code of the malware itself, you have to run it through an unpacker and unpack the code, because the packer will have all the code where you can see what that malware's capabilities are is compressed or sometimes encrypted. And so you have to run it through an unpacker. And so it's always good to look at your strings output, because sometimes the adversary will use a common packer. And so they've used UPX here. And strings has also shown me that it has UPX version 3.91. So now I've done a short circuit. I've taken a shortcut in my malware analysis process, because I don't have to go kind of look around and reach around and try to figure out what type of packer was used. I know, obviously, they could have taken a hex editor and changed this and obfuscated this information, but at least now I can try UPX391, and lo and behold, that's the one they used. But you can make, you can shortcut your process by basically cheating a little bit and seeing what they used. Next, I'm going to talk about AV detection. So I consider AV detections a type of static analysis. I know that some AV vendors will say, well, there's more than just signatures, but in Cuckoo reaches out to VirusTotal, and so VirusTotal, most of the engines that they're running on VirusTotal are just looking at the file statically. That I don't believe that they have a VM that's actually running the malware. What you can see here is some of the AV vendors have very general signatures which don't tell you much. So UDS, dangerous object multi-generic from Kaspersky, so there's not much information there. But Trend Micro and ESET both have named this Key Ranger A, and so some of the AV vendors will share signatures with each other, and so you'll see that. But also, some of them are very good at making signatures that are very specific to a family of malware or a specific generation of malware. And so you'll see across a couple of different AV detections a name, and you could, again, take a shortcut in your analysis process and stop here and then Google that. Because chances are there's other researchers that are sitting here in this room that may have run into this exact same piece of malware yesterday or last week, and they published an entire paper on it about its capabilities, its C2 infrastructure, and such as this. And so you'd be able to then take a shortcut and not have to reproduce someone else's work, or at least build upon stuff that other people have started. So next I'm going to look at a couple of other ways of looking at things statically. And I'm going to pivot here into macOS malware. Pivot away from macOS malware. This is a PE, portable executable Windows piece of malware. And so here we have sections. So the PE sections in Windows malware, you can take a hash value of each one of the sections, and then you can compare that hash value to all of the other hash values of sections in a malware repository, and then you can see what other files that you may have collected at the same time or collected in the past that have the same hash value for that section. And so then you can say with, some sort of certainty that these files, these 52 files that I've found, are related or potentially related in some way to the file that I'm working on now. And so I can then take these other 52 files. If they're from my malware repository, I probably have already run them through an AMA. But if they're from someone else's, then I'll want to run them through my AMA and determine, are they related to this file that I'm looking at right now? And can I get more infrastructure from these extra files in addition to the one or two C2 callbacks that I found in the file I'm looking at now? Again, PE resources. So this is another an RT_version. I know malware authors will just make stuff up. I mean, this is probably there's a legitimate reason to have an RT_version resource, but malware authors don't usually follow spec. But at least I can see that taking the SHA-256 of this particular resource, I can then look again in a malware repository and I find 99 other files that use this particular resource. And again, now I can compare the file I'm looking at to these additional 99 files. By the way, there's quite a lot of overlap between that 52 and 99. And so then again, comparing that, if you have overlap between those two, you have a little bit higher certainty that these are related. And then this last one, so there's a lot of file metadata and there's a lot of very interesting file metadata. And I want to show you a technique that I hope you take with you. So in the PE header is a timestamp. I understand that this timestamp can be forged. I see it zeroed out a lot. But sometimes the malware author does actually have his machine reaching out to NTP servers, and he's got a very precise time and puts a very precise timestamp of compilation and linking. And so you can see this is, March 7th, 2016 at 9:41 and 34 seconds. And then you can look because, you can see in most of the public malware sandboxes, such as Malware and other places, payload security, virus total, you can see the time a file was submitted to that public site. And so you can compare the timestamp between the header and the time it was submitted to that particular service. And so this one, as you can see, 9:41 and 34 seconds, it was then submitted to VirusTotal at 9:42 and 47 seconds. And I doubt that this actually went out onto the internet, infected someone, they reported it to VirusTotal in that amount of time. Very, very, very unlikely. So what they do is VirusTotal gives you a hash value, which represents I believe the IP address and maybe a little bit more information about that individual or that entity that submitted the file. And they also give you this particular hash for all the files that are submitted. So now I know that this particular piece of malware was submitted by this hash from the web and from Russia. And so now I can track, if I'm looking at files that are submitted to that same service, I can look at any file that's submitted by this individual or this entity, and I know that that is probably related to the malware that I'm already looking at, or at least it's malicious. I know it's malicious even if it's not detected by any AV engines, even before I've sent it to my own AMA and know what its behavior is. So, there's a few flavors of Cuckoo Sandbox. Right now, still the stable version is 1.2. There's a next generation version 2, which is at release candidate 1. I encourage everyone to go ahead and move to release candidate 1 and go ahead and report bugs. It's an open source project, and so open source projects rely on you to use the software and report bugs back. So please do that. Cuckoo Modified is a fork of the Cuckoo, the plain vanilla Cuckoo. There's a few reasons for the Brad Accuvant or Spender Sandbox or Cuckoo Modified to exist. Many of the changes that were made in this are upstreamed into the version 2. So there's there's some benefit from using both. I would say right now, if you were to deploy Cuckoo, deploy the version 2 or deploy version 2 and Cuckoo Modified. So there's a few things that you get from Cuckoo Modified. There's normalization of registry and file paths, and I'm going to talk specifically about that next. There's some really interesting nuance that you can get from doing this process of normalization. You also have 64-bit analysis, service monitoring. There's a better API. You can use Tor for outbound network connections. And then finally, it has a Malhure for heuristics integration. So specifically, I was talking about why normalization is really good. And so normalization, as you can see at the top, these two JPEG files, by the way, these are not JPEGs, but, malware will drop things and just call it .jpeg. But, so bonzo / whatever, random string.jpg, these two locations are, for all intents and purposes, the same location on different versions of Windows. So if you're collecting information from a set of sandboxes, or if you're collecting data from your own sandboxes that are running Windows XP, and then I'm also talking with a fellow researcher and his Windows boxes are version Windows 7, we're going to have conflicting data sets that I won't be able to do analysis across the two data sets because the paths are going to be different. But if you normalize the path and replace the part that is slightly different across the two versions and replace it with an environment variable, one of the standard environment variables for Windows, you then have one single path from many different versions of Windows, and you can do data analysis across those because you've normalized your data set. So, Cuckoo Next Generation, a few interesting other things, support for Mac OS and Linux. These are really cool things. You also have Suricata, Snort, and Moloch. You can do SSL decryption because it includes man-in-the-middle proxy, which is a Python implementation of a man-in-the-middle proxy. You have VPN support. VPN support is very important Because if you are running a malware sandbox, you don't want your adversary to know the IP address of your sandbox, because eventually they're going to figure it out and you'll not get data from it. They'll start either attacking you, or they'll bake your IP address into their C2 or into their malware, and then it just won't run if it knows it's on your IP address. So what you want to do is rotate around through a lot of VPNs, and it's really convenient to use all of those, hide my privacy and PIA and all this, everything, whatever, all the ones for using BitTorrent and whatever sort of like surfing porn you want to do. Just get those really cheap ones and start rotating around all of them and burn a lot of IP addresses, but you'll be able to distribute your malware traffic across a lot of different VPNs. Also, it provides, just like the Cuckoo modified, 64-bit analysis, and it's a lot of fun. So these two tools that I'm going to talk about now work in concert with Cuckoo. So first of all, many pieces of malware will have anti-analysis techniques baked into it. So if it observes that it's in a sandbox, or if it observes that it's in a VM, or if it observes that it is in a certain IP address range, it is going to not detonate. It's not going to call home. It's not going to activate. It's not going to do what it's supposed to do. So what you do is run Paranoid Fish, or PAWFish, which is an executable which implements all of these different anti-analysis and anti-VM, anti-debugging techniques, and it will go through and test for each one of these known techniques that malware uses, and it'll give you a report that's displayed on the screen. So you'll have a screenshot of this, and you'll have all these okay, and then as you can see here, there's one red traced flag here for a registry key, which has told PAWFish that it's running in VirtualBox. And so now you know, out of all of these things, you're not detected, but you're detected on this particular registry key. So you need to go in there and adjust that registry key and obfuscate it so malware can't find it. And that's what this does. This next tool is called VM Cloak. And what VM Cloak does, this is a project that's run by one of the members of the Cuckoo development team. And so what it does is it basically goes through, and all of these common spots, registry keys and services and paths and locations and things that malware tests for to determine that it's in Cuckoo Sandbox or VirtualBox or KVM, etc., it goes and obfuscates all of them in an automated fashion for you. The other thing it does is it builds your VM, so it's a bit like if you're familiar with Vagrant and you do Vagrant up, and, Vagrant sits there and configures your VM, and then you pop up with a little command prompt. It feels a bit like that because it's building a Windows box that's ready to go in your Cuckoo Sandbox, fully configured, software installed. You have the Windows key has been installed if you give it the Windows key. You've got Office installed, all the different versions of software that you want. So you basically run VM Cloak. You go get coffee, because it does still take a little bit of time for Windows to install properly, and then you come back and you've got a VM that's ready to go to sandbox malware. Another good thing that I use it for is I have a lot of different versions of software that I want to run malware against, and I don't want to have to go back and reinstall the operating system many different times. So I have a very large array of VMs, each with a slightly different version of software in it. And so to do that, it would take a lot of work to go through and do that manually. But VM Cloak, you just write a script with each one of the flavors that you want, and I wouldn't say go get coffee. I'd probably say go to a movie or 2 movies and then come back, and then eventually you'll have all of these VMs completely built in an automated deterministic way. So these two are very, very important tools for malware analysis. So this is a list of some of the outputs that you get from Cuckoo, and remember, we're talking today about how to connect these different tools together, and so which one of these tool outputs feeds into some of the inputs in another tool. So of course, you're going to have dropped files, and what you want to do is be careful with dropped files, because you don't want to get yourself into a nasty infinite loop of sending a drop file that's slightly different than the original file back to Cuckoo, and then it drops a file that's slightly different than that, and then send it back into Cuckoo and do this forever. So you want to have a little, you want to have some sort of regulation there that says after maybe 6 generations of parent-child that you stop and don't send the child back into Cuckoo. And some malware will actually just sit there and either change some of the padding or do some other changes to its own file structure and not change the code at all, but change the file structure enough that it'll have a different hash value, but it'll be the same malware. So it'll just drop, it'll drop forever versions of itself. And so anytime you see that, you probably want to also be alerted, because you want to, it's not going to happen very often, so at least you want to go and look and see what is it that's happening here. You're also going to get PCAP, so you want to run that through Bro, because there's slightly different things that you can get from Bro. Also, you'll get a memory image. I would say don't really worry about this memory image. This is where I was saying one of the nuances of using volatility by itself compared to using Cuckoo is that Cuckoo actually pollutes the memory image because of the CuckooMon DLL that it uses to instrument and monitor all of the malware behavior. So you're basically, they say you can't really observe something without changing it. So when you're observing something in the way that Cuckoo does, you've actually changed the memory image in a way that for volatility to analyze the memory image that Cuckoo that Cuckoo gives you, it's perfectly fine for Cuckoo's, for Cuckoo's purposes. But some of the tools that you'd want to use in volatility, it's better to take a clean memory image where there's nothing in there, that it's a golden image, and then run the malware in there, and then you'll have a comparison, so you can compare the output from some of the tools. And I'll go into one of those techniques in just a moment. So Thug is a low interaction honey client. It pretends to be a browser. It's written in Python from the bottom up. And the point of it is to get a payload from a drive-by or get the malware file from a URL, basically to convince that C2 or to convince that drive-by that it wants to give you the payload. So I like to call it a wolf in sheep's clothing. It's basically pretending to be something that it's not. So you can change the user agent. You can also simulate different versions of software, and it will tell, it basically uses V8 to do JavaScript. And so it will tell a browser, it'll tell the server, I have a particular version of Flash, or I have a particular version of Java running. I have a particular version of Adobe Reader. And so you'll be able to collect the payload that particular drive-by is trying to give you. So up here, there's 2 links, useragentstring.com and also browserinfo.net. The first one is a library of user agent strings collected over a lot of time. So these are valid user agent strings by operating system and browser version. And you can see many different legitimate browser user agent strings. And so if you need to find a specific one that malware is looking for, you can go here and find exactly how that user agent string is structured, the real one. And the second one, browserinfo.net, this is a list of user agents that are most common, and obviously this is just the sample size of visitors to this particular website, but it's a pretty good sample size, and so you'd get a pretty good idea of what the most popular browser is right now. So if you need to use one of the more popular browsers as a user agent string, you can know that choose the ones from this list. So this is the list of, as of the current version, all of the different operating systems and things that are configured in Thug already. You can, of course, give it your own free text entry for user agent string, but you can pick these that are prepackaged. That one, it doesn't show up very well, but this is Windows 7 and Firefox. I've had a lot of good work with that. Also IE 8 and Windows 7. So the output of Thug, you get payload files, so you're going to want to automate sending payload files over to Cuckoo for analysis. And then you also get further visited URLs. There's a number of different outputs here. MAEC is a subset of sticks. So it speaks not Stix taxi, but it speaks the Stix format. And then HP feeds is a very interesting output. So HP feeds is it's a publish and subscribe protocol, which is developed by the HoneyNet project. And HP feeds is basically telemetry coming out of sandboxes and analysis tools, malware analysis tools. And you basically can publish, and then other malware researchers can subscribe to your HP feed coming out of your Thug instance or your Cuckoo instance or your X whatever sort of malware tool you've got speaking HP feeds. And what's interesting is there's a site called HP Friends, which is basically Facebook for malware researchers. So it's a social media site where you can basically publish and subscribe to each other's malware feeds. And so it's a very interesting site. And you can friend people on there and stuff like that. So, and when, you basically, you're on there with a bunch of other people, probably some of the other people in this room, and, you can chat about malware and then, publish data from your sandboxes. So, this is my favorite part of the talk. So I'm going to talk about Bro. Very, very powerful tool. This is an extremely powerful tool for both network security monitoring and how I'm going to talk about it for malware analysis. So it's a network security monitoring framework. It processes live packet capture, so you can point it at a network device, and then you can run that in promiscuous mode and do live packet capture. You can also have a recorded packet capture, so a PCAP, and you can look at the data in a PCAP and basically analyze it and convert that into a set of Bro logs. So Bro is, for all intents and purposes, a set of scripts that are written in the Bro scripting language, and each one of the scripts basically has an output of a Bro log. And a Bro log is essentially, it's sort of like a space-separated file. It's not exactly. It has a header and a footer, which give it an idea of like what the columns mean. But for all intents and purposes, it's basically a table of information about the protocol or the connections or the different things that particular Bro script was looking for. So what I want to do is highlight, and I know this is not the automated portion of this, but I want to kind of highlight the power of Bro and how it can be used for malware analysis. So this is dokument.xls, so it's an Excel file. That means document in Russian. The source of this PCAP is from hybridanalysis.com. It's a free online malware analysis server. And then the SHA-1 is right there. So if you want to, you can go there, collect this file, and follow along after this talk and reproduce my results here and check my work. So what can we learn from PCAP only? Basically, without looking at the file itself, not knowing any of the file structure, not knowing anything about the file at all except for the file name, so I know it's Excel, what can I learn from listening to the file talk? So, where do you begin? Where do you begin with Bro? So the first thing you want to do is look at the con.log, and con.log shows you each one of the connections that was made in that particular packet capture. So the first thing you want to do is take the benign traffic and remove that. So you want to toss away all of the stuff that isn't malware talking. You want to toss away the stuff that that's the operating system talking, or talking to itself, or talking to other devices on the network. And so you can see there's a bit of UDP DNS traffic, some IPv6 DNS traffic, there's some pinging going on, and some broadcast traffic. So you want to toss all of this out. So the rest of this, starting with DNS traffic. So there are two host names that were resolved here. So we want to take a deeper look into what was going on in those two host name DNS resolutions. You can also see two HTTP connections. So two times the malware reached out to a web server. So typically, if you have a Excel document reaching out to a web server, you are in trouble, deep trouble. And then this is what I call the WTF traffic. Bro is very good at identifying what the protocol being used is. And so over there, if the service is blank or dash in Bro doesn't know what it is, so that's probably not legitimate traffic. It deserves a deeper look. So let's take a look at the DNS log first. And as you can see, you have a resolution for the hostname s01.yapfiles.ru. I'm going to go ahead and guess that this is a legitimate website because they appear to be using round-robin DNS. And so I do know some malware C2s that have done that. But I mean, I have the gut feeling at this point that this is legitimate. But then we have rmansys.ru with one IP address. That's pretty suspicious. Also, again, like I said, if you have an Excel document that you've opened and it starts talking to servers in Russia, you are really in trouble. So what I did was I went and saw what is yapfiles.ru. So I go there, and it is a image and video sharing site. And here, I know you might not be able to read Russian, but that says upload file. And so this is a place where you can upload and look at other people's uploaded files and videos. So that's something to keep in the back of your mind, to do a little bit more investigation into what's happening there. So the next thing, I went to rmansys.ru, and lo and behold, this is the website for Remote Manipulator. If you haven't heard of Remote Manipulator, this is in the same class of software, or the same class of malware, the sort of gray area stuff as Hawkeye Keylogger. These are pieces of software that are sold in the sort of gray area where somehow the companies that produce this are not being punished for producing it because they're selling it as something that you would spy on your children with, or to spy on your wife, or something like this. And so it exists in this sort of gray area where there's a company, they have developers, they have a phone number, they have a website, et cetera, et cetera. So we now have a pretty good idea. So probably the payload that we're looking for, that this Excel document downloaded, is a remote manipulator Trojan. So we then want to look at the HTTP log to see what it reached out to those two web servers and what it got from them. So as you can see here, at yapfiles.ru, it reached out and it grabbed a JPEG. But Bro's pretty smart, and Bro is saying that that's not a JPEG. It's the MIME type for that particular data stream is application x DOS exec. So what I want to do at this point is verify this. And so the next thing I want to do is look at the files that were carved out of that network capture. And so those files are dropped into a folder. Oops, sorry, I'm a little bit out of order. So I went and looked at this at yapfiles. And lo and behold, the image, blah, 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 cannot be displayed because it contains errors. Definitely contains errors, like it's not a JPEG. So the next thing you want to do is go and find the file that was carved out of the network traffic. And so one of the things that Bro does for you is it gives you UIDs. And this particular type of UID is called the FUID, or file UID. And what this allows you to do is any other location in a Bro log or in the carved files, it will show you how that particular file or row in another Bro log is related to rows in this Bro log, because they will all share either an FUID or a connection UID. And so you can correlate logs across each other and relate different traffic to traffic in another log. And so, as you can see, this file UID I've then used to find the file itself that was carved and dumped in extract files, and then I ran the file command to find the magic characters at the beginning of the file that mean that this is a PE32 executable. So it had MZ right there at the top. And so this is definitely not a JPEG, because that is not the file magic for this particular file. This one is an executable. So now I've got a lot more information, and I still haven't seen or looked at the Excel document that is being executed and downloading and doing all of this yet. So there's another thing called the files.log. So if you need to have file hashes to use as file indicators, you can get the MD5, SHA-1, SHA-256, and the total bytes for that particular file and the file name used. So you can collect that information. Now, what we want to do is move on to the WTF traffic and take a deeper look at what is going on port 5651. So what I've done here is look at the traffic using Wireshark. I know I'm cheating here a little bit, but I wanted to visualize what you get from inside that particular TCP connection. And so as you can see, this is, it looks a little bit like angry fruit salad, but this is actually, XML, and so the part in red is the malware, reaching out to the web server, the C2, and then the part in blue is the response from the C2, the command and control server. So I know this is a little bit busy, this slide's a bit busy, but the next slide, I've broken down the information that I collected from this XML traffic. So let's take a look at what we've learned from only listening to the malware speak and not actually looking at the malware itself. So we know that the adversary is likely Russophone. We also know that there's an Office document generating network traffic, so that's a serious problem. We also know that the payload is remote manipulator. We'll be able to confirm that if we run that particular file through Cuckoo and look at it further. And then down here at the bottom, this is the stuff that I gleaned from that XML traffic. And as you can see, they left, they're not too smart because they left a lot of very unique information about both the malware implant and the C2. So you have C2 server version, you have C2 server license number, C2 internal ID number, Trojan version number, Trojan ID number, internal ID number. So using this, if I were to discount the stuff that's the Trojan information, because that's probably a one-off, I will now be able to tell using a snort signature or making a bro script, I will be able to find future usages of this same C2 if it shows up on a different IP address, if it shows up on a different domain name. I will be able to see the traffic and correlate that traffic to this attack using this information because that is very unique. All right, so let's move on. And I've collected all of the indicators that we talked about earlier, and there's a little bit of a nuance here. So I have marked s01.yapfiles.ru. I've only given it one skull suspicious because it's a legitimate site. I don't want to black hole it and have it, blocked at the firewall. I want it to just be if it is observed, I want it to be further investigated, but I don't want it to be blocked. This is my bro.local, local.bro. I spent a lot of time combing through every single feature of bro and making sure that I have loaded and configured everything that I need to do for malware analysis. I encourage you to take this, and bro doesn't come out of the box creating a SHA-256 hash, so that little bit at the bottom is actually adds a SHA-256 hash to the files.log. So you can download this. This is one of the first things that I've begun uploading to my GitHub page. There's a GitHub repo called Open Source Malware Lab where I'm going to continue to publish parts of this system. And the oldest one that I published there is the bro log. So the bro configuration. So please take my bro configuration. If you make any changes that could improve it, please do submit a pull request. So bro's output, you get multiple bro logs, variety. Some of the important ones are con, DNS, HTTP, and file. You will get extracted files that you're going to want to send to Cuckoo. It also carves out SSL certs. And importantly, you can change a setting in local.bro, and then you can have bro emit JSON instead of the tabular typical bro output, and so you can take that well-formed JSON and shove it directly into Elasticsearch or other other document stores. So last, let's look at volatility. So volatility is a memory analysis framework. It analyzes artifacts from live memory and from memory images. And I say it actually does live memory because there's a component of the Recall project, which is a competing open source project to volatility. There's a component in there that actually takes live memory, and you can pipe live memory into Recall or volatility and observe artifacts from it while it's running. Not just from a captured image, which is very powerful. And so it supports Windows, it supports Mac OS, it supports Linux. Very powerful tool. And so let's do that same exercise that we did earlier with Bro, but let's look at it using volatility. So I have a analysis target of b.exe, and on a side note, if you have a executable file that is one character.exe, like 2.exe or 7.exe, that is malware. That is always malware. But let's look. This is, again, I downloaded this from Hybrid Analysis. You can follow along yourself by going and getting this file. There is the SHA-1 so that you can find it yourself and reproduce what I have talked about here. So, of course, some of the things that you get from coming to a conference like CircleCityCon is I have banged my head against things numerous times, and so you don't need to bang your head against the same thing. So, you can't just take a memory image from VirtualBox. You need to do a little bit of dance before volatility will be able to analyze it. So these are the commands that you need to run to dump the memory image from VirtualBox. So that's the first command. And then the second command changes, changes that memory image into a DD-style memory dump that volatility can analyze. So please do this rather than banging your head against the same wall that I did. So the first thing that I looked at, and remember, I want to use volatility by itself and create a memory image of clean and before the malware is run so that I can compare the output of one of these tools from before and after the malware has run. And so, as you can see at the top, this is a diff of the output of the PS list tool in volatility. And so these three processes have stopped, and now Explorer.exe is running. So I did not run Explorer.exe, I ran a piece of malware. As you can see here, this is malfind, which looks for processes that have been injected. And as you can see, both of these Explorer.exe processes have been injected with code that is executable. You can tell because it has MZ. This is the file magic for PE executables. And so what I did was I dumped that process, dumped both of those processes, and ran those through AV scanners. And I found that this one at 80,000 is caught by Avira and Qihu 360, and then this one is also caught by Qihu 360. So this is malware that's been injected. These two processes have been injected. Now, what I want to do is look at NetScan, which shows you all of the network connections that volatility is able to find in the memory image. And so evidence of network connections. So now we have 216.170 blah, blah, blah. So this is malware C2 traffic where it's reaching back to its mothership. So I want to review what I've found so far just using volatility and not actually, well, in a way, I'm looking at the malware file, but I'm looking at the malware file and what it's done in memory. So, this sample uses process injection. It injects Explorer.exe. So this is a tactics, techniques, and procedure that you can use to relate this to other of the same piece of malware. We also have a command and control IP address. And so you can use this as an IOC to protect yourself. You can put it on firewalls, et cetera, et cetera. So this is a list of other tools. I will be publishing these slides next week, so you can come back and look at this. I will just skip over that. there's a number of different files that you can pull out of memory, DLLs, processes. All of these can be run then through Cuckoo. And then you can extract URLs from the IE history if at some point the, IE was used in some way. This is a little bit more important for, forensic work looking at a machine rather than malware analysis. But, you also get suspicious mutexes, etc. So I want to tie this all together. And you'll notice that I've separated Cuckoo and volatility into two separate sets of swim lanes. The reason for that is I found that if I combined all four tools into one set of swim lanes, it just looks like a pile of spaghetti. So to make it a little easier to understand, and I hope you'll be able to kind of tie this all together anyway, but you start with a file. It's uploaded to the sandbox. That sandbox performs static analysis, performs dynamic analysis. You want to take that output and send it to your threat intelligence platform. You then want to look at any URLs using Thug, and the PCAP from there you want to analyze using Bro. At the same time, those two tools are going to do their analysis, and then at the end, you're going to want to have some logic here in your in the system which looks and sees, have you seen this particular file before? If you have seen it before, then send the output from this particular tool to your threat intelligence platform. If you haven't seen it before, send it to Cuckoo. And then in the same way, you're going to see that same sort of pattern repeating itself. So starting with volatility, you upload the malware, you upload the memory image, you do memory analysis. That will get you URLs and files. If you've seen them before, send it to your tip. If you haven't seen them before, use the appropriate tool to analyze those, and rinse and repeat this process. So there's a few things that I've learned here. You can use any message queue you like. One of the ones that I prefer is 0MQ, and 0MQ is not good for transferring the malware files and the PCAPs and stuff like that. What you want to do is transfer the location, so set up a Nginx or Apache web server, drop all of your big files in there, and then in your message queue just tell the next tool where to go pick up that particular file itself. Each one of these tools has the way to talk to Elasticsearch. So Cuckoo, you would use Cuckoo modified, or you write your own report plugin. Thug has Elasticsearch native output. Bro can export logs, like I said earlier, in JSON format. Also, volatility, there's a way to have volatility also create JSON format output of each one of the tools. So all of these can go directly and speak JSON to Elasticsearch. I glue everything together with Python 3. I prefer 3 over 2. So finally, do you have any questions about what I've talked about so far? Also, this is the blog where we will be posting, I'll be posting my slides and probably a write-up, a general outline of what we've talked about here today. Also, follow me on Twitter, Malware and then follow Threat Connect, so Threat Connect's at Threat Connect on Twitter. Questions? Yes? So the question was, is Pwns and VMCloak part of Cuckoo Next Gen? So no, they're actually separate projects. Pwns is a totally separate project. VMCloak is written by one of the members of the Cuckoo project, and VMCloak, actually the current version of VMCloak can register the VM that it creates with Cuckoo if it's running on the same server as Cuckoo, and so it integrates very tightly. But no, it actually isn't part of the Cuckoo that you download from the Cuckoo project. Other questions? Yes. So, okay, the question was, how do I isolate malicious or potentially malicious activity from the malware from natural, normal activity that Windows does on its own? It's a very good question. One of the things that you can do is basically make sure that you know what Windows does normally. Understand what Windows does. One of the best ways, and I repeat what I learned in my Grem class, is know good and then find evil. So what you want to do is learn, look and observe what Windows does. Don't run malware in a VM. Run a VM for, a few hours, and then look and see and learn what normal Windows activity looks like. And then you can see what the malicious and odd and strange stuff that happens after you run the malware. Another thing is run it very quickly. Right as soon as you start up the VM, run the malware so that not a lot of this other stuff has time to even happen. Any more questions? All right, looks like it's 3 o'clock. Thank you very much. By the way, don't leave quite yet, but come around here to the corner. We have a whole bunch of awesome